Hello friends, continuing with the topic of semiconductors. Today we come to its fourth part, p-n junction. Previously we have studied about p-type material and n-type material along with their characteristics. Today we join both p-type and n-type and we will form a junction. Now, how p-n junction is formed? Let us try to understand. When a p-type material and n-type materials are joined together end to end to form a uniform crystal lattice, a p-n junction is formed as shown in diagram. I repeat, when a p-type material and n-type materials are joined together end to end to form a uniform crystal lattice, a p-n junction is formed as shown in diagram. Now look at the diagram. In p-type material, we know there are majority holes shown by positive charges and negative ions shown by minus in circles, and electrons and holes due to thermal agitation shown by plus minus. In n-type material, we have majority electrons shown by minus sign, positive ion shown by positive shown by plus in circle, and minus plus are the electrons and holes due to thermal agitation. Now, red plus is due to doping and minus in n-type is due to doping, and plus minus and minus plus are due to thermal agitation. So, this is how p-n junction is formed initially. Now, what happens when p-n junction is formed? Then what happens at the junction? We have to look into it. A potential barrier is developed. Now, what is potential barrier? Let us try to understand. Potential difference developed across p-n junction as soon as junction is formed, which prevent the flow of charge carriers across the junction, is known as potential barrier. I repeat, potential difference developed across p-n junction as soon as junction is formed, which prevent the flow of charge carriers across the junction, is known as potential barrier. Now, how potential barrier is formed? Let us try to understand what actually happens at the junction. Now, let us try to understand formation of potential barrier. As soon as the junction is formed, due to concentration difference between charge carriers, electrons from n-type and holes from p-type start diffusing across the junction. Now, how there exists a concentration difference? Let us try to understand. Holes are in majority in p-type and holes are in minority in n-type. So, there is concentration difference. So, holes will move from higher concentration to lower concentration. Similarly, electrons are in majority in n-type and electrons are in minority in p-type. So there is concentration difference. So electrons will start moving from n-type to p-type. So this is how, due to concentration difference, electrons and holes, they start diffusing across the junction. On the way, electrons and holes get neutralized. That is, an electron hole pair gets annihilated. The kinetic energy of electrons is released in the form of infrareds. These are infrareds which are invisible to human eye. Now, as a result of neutralization of electrons and holes at the junction, an ion core is formed with negative ions on p side and positive ions on n side. Now suppose an electron from n side and a hole from p side is annihilated while crossing the junction. There is a negative ion left in the p-type material and positive ion is left in the n-type material near the junction without any charge carrier. Similarly, another electron and hole pair get annihilated, then another negative ion in p side and positive ion on n side becomes without charge carriers near it, and the junction area becomes depleted of the charge carriers. This is what happens across the junction due to annihilation of electron hole pairs. This ion core prevent further diffusion of electrons and holes across the junction. Now how it prevents? Now negative ions on p-type will repel electrons coming from n side, and positive ions on n side will repel holes coming from p-type. So it prevents further diffusion of electron and holes across the junction. This ion core, which is depleted of the charge carriers, results into a development of potential difference across the junction. This potential difference which is developed across the junction due to ion core have been shown by the battery. Now this potential difference developed across the junction is known as potential barrier, which is reflected here by VB. This side is negative, this side is positive. So there is development of a potential difference across the junction due to ion core, which is reflected by the cell as shown in diagram. Now this potential difference VB, now for germanium junctions VB is 0.3 volt and for silicon junctions VB is 0.7 volt. Look at energy level diagram. This is energy level diagram. Now in n-type material here is conduction band and here is valence band, and in p-type material here is valence band, here is conduction band. Now electrons from conduction band of n-type material, because these are free electrons, so if they are to go to conduction band of p-type material, they have to overcome an energy barrier of EB equal to small e into VB. So this is the energy barrier it has to overcome. Energy, more than energy barrier is needed for the electrons to go from n-type material to p-type material. If electrons are to shift from conduction band of n-type material to conduction band of p-type material, energy more than energy barrier is needed. And where from we get this energy? We get this energy by application of electric fields. Okay, that we'll see later on. Now depletion region. What is depletion region? Region around the junction which is depleted of the charge carriers is called as depletion region. Now the region surrounded by ion core is depletion region because there are no charge carriers in this region. Now depletion layer. The layer across the junction which is depleted of the charge carriers is known as depletion layer. Now biasing. What is biasing? The application of electric field across p-n junction in order to make current flow through the junction is called as biasing. I repeat, the application of electric field across p-n junction in order to make current flow through the junction is called as biasing. Now here you look at this diagram. We have applied electric field whose positive is connected to n material and negative is connected to p material. We call it as reverse bias. And look at this diagram. Here positive of the battery is connected to p type and negative is connected to n type. We call it as forward bias. Okay. So this is how we apply electric field in order to make current flow through the junction. Now type of bias. We can apply bias, that is electric field, across p-n junction in two different ways. First is forward bias, second is reverse bias. We take up one by one. First we take up forward bias. When p-type material is connected to positive terminal of the battery and n-type material is connected to negative terminal of the battery, the kind of bias is said to be forward bias, as shown in diagram. Here this is forward bias where p is connected to positive terminal of battery, n is connected to negative terminal of battery, and this is, we have shown potential barrier. This is how we can apply forward bias to p-n junction. Now reverse bias. When p-type material is connected to negative terminal of battery and n-type material is connected to positive terminal of battery, the kind of bias is said to be reverse bias, as shown in diagram. Here is the diagram for reverse bias. Here p-type material is connected to negative terminal of battery and n-type material is connected to positive terminal of battery. So this is reverse bias, RB for reverse bias, and PB for potential barrier, RB for reverse bias. So this is how we apply a reverse bias to a p-n junction. Assignment 14 continued. Question number 16. How potential barrier is formed across a p-n junction? Explain. Question number 17. Differentiate between depletion region and depletion layer in case of a p-n junction. Question number 18. What is bias? With the help of circuit diagram, distinguish between forward bias and reverse bias of a p-n junction. Question number 19. How is the band gap Eg of a photodiode related to the maximum wavelength lambda m that can be detected by it? Now how to solve question number 19? You know Eg is equal to h nu, or it is equal to hc by lambda. So you know the value of h, you know the value of c. Calculate lambda m, and that will be equal to HC by EG. So that will be the maximum wavelength that a photodiode can detect. Photodiode is a device which can convert light energy into electrical energy. Okay. Thank you so much. Next time we will take up operation of PN junction under forward bias and reverse bias conditions. Till then, goodbye and good luck to you.